All right, let's go for example 5. I skipped example 4. I'm going to leave it that way. So an ultimate Frisbee team consists of 7 players. A team is formed by randomly choosing players from a group of 8 men and 7 women. So we have to make a team of 7 players from 8 men and 7 women. How many, or determine the number of ways that 7 players can be chosen from the team. So there's really no constraints. So really the team, if I have 8 men and 7 women, I have a total of 15 players. How many different ways can I choose 7 players for the team? Well, it's going to be 15 choose 7s because I'm just choosing any 7 out of the total of 15. Now, determine the probability that the team is exactly 3 women. Now, exactly 3 women, it's going to imply something about men. Now, remember that our team is 7 players. So really, what does that mean? It means 3 women and 4 men. That's what it really means, right? It's implying. So the probability of having exactly 3 women is going to be equal to if I was to choose exactly 3 women, I need to choose 3 women. So there's 7 total. So I'm going to calculate the number of ways that I can choose 3 from a group of 7 women. So that would be 7 choose 3. And exactly 4 men. So I need to choose 4 men from a group of 8. So that would be 8 choose 4. And these two are multiplied because I use the word and. Now, in the denominator, how many different ways can I make the team? Well, that's going to be 15 choose 7. It's actually going to be there are a total of 15 choose 7 different ways to make the team. So when I calculate this, I'm going to bring my calculator, hit a whole bunch of buttons. I get 2,450 divided by 6,435. All right, we're starting to mean business here. Like, this is probably a very difficult lesson. So we're going to move on beyond that, and we're going to talk about complementary events. Really important idea. So recall that the complement of a set of outcomes in which the event does not occur. So if A occurs, the complement of A is everything except for A. So, pardon me, if A is equal to 1, 2, 3, 4, and the universal set is the digits 1 through 9 inclusive, then the complement of A, that A, comma, it looks like, will include everything that's in the universal set that's not A. So 5, 6, 7, 8, and 9. So if a problem seems complicated, sometimes it's really useful to see if we can use the complement. Now, the probability of the complement is just simply 1 minus the probability of A. So I'll give you an example. Rolling a dice. What is the probability of rolling not a 1? Well, you know the probability of rolling 1 occurs once in every 6 times. So what we could do is we can just take 1 and subtract 1/6, and we get, well, the probability of not rolling a 1 would be 5/6, right? So the probability of rolling a 1 would be 1/6. But the probability of not 1 is going to be 1 minus 1/6. And we know that there's going to be 5 other different sides of the dice. So really you have a 5 out of 6 chance of rolling not a 1. All right. Find the probability that a 7-digit number has at least 1/8. Wow, that seems overly complicated. But I'm just going to write down a 7-digit number, right? So, right, this is a 7-digit number. Oh, and this actually has 1/8, so this would fit in, right? So here, let's talk about digits. What values of digits can I have here, right? Each of these digits can have 0 through 9, except for the first one, right? The first one has to be 1 through 9, right? Because if it was 0, it would be a 6-digit number. For example, 013, you would probably read that as 13, not as 0 hundreds and 13. All right. Wow, this is going to be very, very challenging. So I could split this up into a whole bunch of cases, can't I? So the probability that a 7-digit number has at least 1/8, well, I could see case, I could figure out the probability that a number will have at least, or will have 1/8, and then I can figure out the probability that a number has 2/8. That seems way too hard. So here, an important idea is the probability at least 1/8 is going to be 1 minus the probability of no 8s. The complement of having at least 1/8 is having no 8s. So, all right. I'm starting to get this. Now, this is still a tough question, no doubt. I'm just going to try to create some room here. The probability of no 8s. So I'm maybe going to underline this in pink. So the probability of no 8s, I'm going to try to work over here, and if I need more space, I'm going to write it over to the right. So the probability of no 8s is going to be the number of ways that I can make a number that's no 8. So a 7-digit number. So I'm going to have 7 decisions, 1, 2, 3, 4, 5, 6, 7. And how many ways can I make a number with no 8s? Well, in that first digit, remember, it has to be numbers 1 through 9. So 1 through 9, there are 9 numbers, but it can't be an 8. So there's going to be only 8 choices left for us, right? 1, 2, 3, 4, 5, 6, 7, 9. And then after that, digits. Remember that this next number can go be 0, 1, 2, 3, 4, 5, 6, 7, 9. If you count those up, there's 9. And then there's 9, and then there's 9, and then there's 9 left. Making the same argument as this. So that's the number of ways I can create a number with no 8s. Now, the probability of no 8s is the total number of ways I can make a number with no 8s divided by the total number of 7-digit numbers. So I have to make 7 decisions. So if it's a 7-digit number, this first number has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. And if you count those up, that is 9. It cannot be 0. Otherwise, it wouldn't be a 7-digit number. Now, any number beyond that 9 can be any digit 0 through 9, and there are 10 of those. All right, so I'm going to take this, and I'm going to use my calculator. Here's the numerator. That's the number of ways I can make a number with no 8s, divided by the total number of 7-digit numbers. So I'm going to take that in my calculator, punch a whole bunch of buttons, and what I get is 1 minus the value of the numerator is 4,251,528 divided by 9 million. And if you want, in decimal form, take out your calculator, this will be equal to 0.528. Whew, that was tough. Okay, example number 7. So just flip the question around, and maybe it's going to be easier. When I say flip, just look at the opposite or what's not included. And if that seems plausible, that's probably a way to go. The Yip Club is lining up for a photograph. There are 8 members, including Sarah and Drew. The probability of Sarah and Drew sitting together. Well, that's great. It's a great question. The probability that they sit together. So the probability, Sarah plus Drew. Now, I'm getting lazy here. I should probably put Sarah and Drew together. So Sarah, okay, so we have 8 members. 1, 2, 3, 4, 5, 6, 7, 8. We can treat them as letters. Sarah and Drew have to be seated together. So really, we have 1, 2, 3, 4, 5, 6, 7 different objects that we have to order. So how many different ways are there to order these 7 objects? Well, 7 ways, right? And remember that one object includes Sarah and Drew. So I could order it Sarah and Drew or Drew and Sarah. It doesn't, how many different ways are there to order this group? Well, that's 2 factorial. Divided by, so that's the number of ways that Sarah and Drew can sit together from a group of 8 people. Now, how many different ways are there so that 8 people can be randomly seated? Well, that's 8 factorial. And if you take out your calculator, well, maybe not, right? 7 factorial divided by 8 factorial, this can simply be simplified to 8. 2 over 8, or 1/4. If not, don't believe me, take out your calculator, try it out. It'll be 0.25. So this is the probability that Sarah and Drew will sit together. Now determine the probability that they don't sit together. Well, here we would just take 1 minus the probability of Sarah and Drew together. And that would be minus 1 minus 1/4. So this is going to be equal to 3/4 or 0.75. See? Isn't this fun? Well, I know that this is very challenging.